All right, we're still on the non-calculator portion of this review. And question number 10 is another arc length formula. And they gave us, nicely, they gave us an explicit formula for the function, and they gave us the limits of integration by giving us this interval. So I set up an integral of the limits of integration being 1 and 3, and then I need the square root of 1 plus the derivative squared. So up here you see we found the derivative. We said that we can pull down the 3/2 times the 2/3. That just goes to 1 times x squared minus 1, and then 3/2 drops a degree to just 1/2. And then I need to multiply by the derivative of my inside function, which is this 2x. So you'll notice I have the square root of 1 plus this entire derivative squared. And I do have some algebra to work out. And if you're ever given an arc length question without a calculator and there's algebra to work out, I promise you that you will always work it out to be a perfect square trinomial underneath the radical sign so that you can actually take a square root and get an even square root and then integrate. So in this case, if I'm squaring x squared minus 1 to the 1/2, that just gets me x squared minus 1 to the 1. And then 2x all squared gets me 4x squared. So now I'm going to distribute this 4x squared to both of these terms here to get 4x to the 4th minus 4x squared plus 1. This is a perfect square trinomial that I can write as the square of a binomial. So when I then take the square root of this binomial squared, my squared and square root cancel out, so I just am integrating 2x squared minus 1, which integrates to 2/3 x cubed minus x from 1 to 3, and then I evaluate first at 3, so I cube the 3 to get 27 times 2, 54 over 3, minus 3, and then evaluated at 1, I get 2/3 minus 1. So 54 over 3 simplifies to, well, you know what I did? I took 54 over 3 minus 9 over 3. So 54 minus 9 is 45 over 3. That's what got me the 15. And then 2/3 minus 1 is negative 1/3. So I'm subtracting a negative 1/3, adding a 1/3 to my 15 to get my final answer. All right, part 2 of this assignment is actually your practice gateway. So you get a feel for what kinds of problems are going to appear in your gateway. On that note, though, we are putting in some of the new integration techniques that are on the last page of this packet will also be on your gateway. So x times cosine of 3x, this is going to be an integration by parts problem. So I easily differentiate u equals x to du equals 1, and you can put the dx in there. dv equals cosine 3x, which integrates to sine of 3x over 3. So then I multiply u times v to get 1/3 x sine of 3x minus v du. And don't forget to put your constant out in front to make your life easier. So I can integrate easily sine of 3x will integrate to negative cosine of 3x over 3. And that helps me here. The negative cosine multiplied by that negative makes it a positive. Remember that sine of 3x went to negative cosine of 3x over 3. So I had a 1/3 times a 1/3, which got me this 1/9. And then don't forget your plus c. For question 2, this is a cyclical problem because this x squared will differentiate away after a couple rounds of differentiation. So I start with my first 2 terms that I'm given. I'm going to differentiate x squared to 2x to 2 to 0, and integrate e to the negative 3x to negative 1/3 e to the negative 3x to the positive 1/9 e to the negative 3x to the negative, there is a negative there, 1/27 e to the negative 3x. Then I have to do my diagonal multiplication here. So I have x squared times negative 1/3 e to the negative 3x. I have 2x times 1/9 e to the negative 3x. And I have 2 times negative 1/27 e to the negative 3x. Then I have to sign each of those positive, negative, positive. So my first term was a positive times a negative. It comes out negative. My second term was a negative times a positive, which came out negative. And my third term was a positive times a negative, which came out negative. So all 3 terms in this one are negative. And then don't forget your plus c. And the last problem over here is actually going to be a u substitution problem. And I know that because I see my inside function and I see its derivative. So my inside function is u, and du will be 1 over x dx. So I just do a direct substitution here. I have the ln of u, which was my inside function, times du, which was the 1 over x dx portion. So you might have memorized, and I know I've gone over in another video, that ln of u integrates via integration by parts, because you'll call your u ln of u and your v 1, and you then, your dv is 1, then your v is x, and your du is 1 over u du. And once you do, I just realized that I needed x values instead of u values. So let me clean that up to make your lives easier in understanding. So your u is the ln of x, and your du is 1 over x dx. So you're going to have uv x ln of x, which we have here as u ln of u, minus the integral of v du. So it's minus the integral of 1, which just goes to u, plus c. So that is how ln of u integrates. You end up with u's in here, but again, we need to replace our u by the ln of x. So you have, instead of u, you have ln of x, and then instead of ln of u, you have the ln of x, and then instead of minus u, you have minus ln of x plus c.